one new item. Now, what we're going to do is expand these expressions. So in the first problem we had, this is called a binomial because it's got two items in it. Or I guess you could say it's linear binomials because there's a linear function here. What we're going to do is we're going to, instead of it being 5 times a binomial, it's going to be a binomial times a binomial. So it's going to be a little more complicated. We're going to have x plus 5 times x minus 6. And the way that we solve this is by doing this process called FOIL. I'm going to post a video that Mr. Hag in the middle school, he created many moons ago, and it's very catchy. It'll get stuck in your head, and you'll never forget what this foiling is. So what foiling is first, outer, inner, last. And with this multiplication, with x plus 5 times x minus 6, what that means is we need to multiply the first items of each together. X is first here and x is first here, so I'm going to multiply first times first. O means outer. I'm going to multiply the outer terms. Well, x is an outer, right? This is the outmost to the left, and negative 6 is the outmost to the right of the whole thing. So I'm going to do x times negative 6. And then inner, right, the innermost, well, 5 is right at the center and x is right at the innermost of this entire thing. And then last would be 5. Oh my goodness. I totally drew this picture wrong. I've been doing this wrong the whole time. I'm going to try to correct this. In my video, you're going to see me correcting this in my video. Oops. I want this to be white. And then I'm going to do a new one, a little bit smaller. Oops, wrong one. I was gonna say, when I was doing it, I was like, this looks different than what I've done before. So, there we go. Let's see if I can move that a little bit. First, outer, inner, last. So then the last terms, right? 5 is the last guy from this set of parentheses, and negative 6 is the last one from this set of parentheses. So it's going to be 5 times negative 6. So when I write my work, I've got x times x, right? That's first. X times negative 6, those are my last. X times negative 6. Inner, 5 times x. And then last is 5 times negative 6. Now, we don't leave it in this form. This is a very yucky looking form. We want to simplify it. So simplifying it means let's multiply each of these together and make them clean cut. So x times x is x squared. X times negative 6 is a negative 6x. 5 times x is a positive 5x. And 5 times negative 6 is a negative 30. Now, like you were practicing yesterday in the delta was combining like terms. And so I've got a bx term here and a bx term here. Let's combine those together so we can put it into our standard form, ax squared plus bx plus c. When I add a negative 6x and a positive 5x, I am adding, like, I'm combining the coefficients. The variable stays the same. I'm combining the coefficients, so the 5 and the negative 6 become a negative 1x. X squared stays the same, and negative 30 stays the same, and this is our end result. I'm going from this piece to a quadratic. Take note of that, right? I went from something that looks nothing like a quadratic to our standard form quadratic, like what we've been working with, which is pretty nice. All right, let's do the next example, and I'm going to correct my mistake that I made before. I knew it looked weird. I can't believe I did that. There we go. All right, so moving forward, we've got first, so x times x. We've got outer, x times -4. Inner, 4 times x. And last, 4 times -4. So x times x is my first. X times -4 is my outer. 4 times x is my inner. And then 4 times -4 is my last. When I simplify those guys, I get x times x is x squared. X times -4 gives me -4x. 4 times x gives me a positive 4x. And then 4 times a -4 gives me -16. We've got our common bx terms here, and that's going to be a common theme. You're always going to be combining the bx terms, the middle terms together after you FOIL here. So -4x plus 4x, those cancel each other out, right? -4 and positive 4 becomes 0. So we just don't have that at all. It is completely gone. So we're left with x squared and a -16. All right, let's look at a couple more examples. When you have x plus 5 to the power of 2, really what that's saying is I'm doing x plus 5 times x plus 5. Let me correct my mistake. Add in our corrector. And we're good. When I am seeing something with a squared, really what that means is I'm multiplying this item, x plus 5, times itself. And so I need to rewrite it as so. I want it to look like a binomial times a binomial, like what I've had before. So I did that. I need to be able to FOIL, right? I don't distribute this 2 to each item. I'll mention that in a minute. So I need to write it out like so and then FOIL it. X times x is x squared. X times 5 is 5x. 5 times x is 5x, and 5 times 5 is 25, right? We've got our first, x times x. We've got our outer, x times 5. We've got our inner, 5 times x, and our last, 5 times 5. From here, we want to multiply these guys out, and that is x times x is x squared. X times 5 is 5x, 5 times x is 5x, and 5 times 5 is 25. 5x and 5x, we can combine those guys together, and we're left with x squared plus 10x, right? Because 5x plus 5x is 10x, and then the 25 is just the 25. Please ask questions if you are wondering about this, but this is really a procedural type thing at this point. A lot of times I'd prefer you guys to be able to discover these things on your own. You're going to remember them a whole lot better if you are the one discovering these things rather than Dielman blabbing about them and telling you exactly what you need to do. But in this case, given our circumstances, this is what we got to do, right? And so you need to learn these items. When you see something, x plus 5 squared, it's really x plus 5 times x plus 5. Just like if I were to give you, x to the power of 2, right? X squared, that's the same thing as x times x. You can split it up into its separate items. It's itself times itself. That is what we are doing here. So let's go to the next example. X minus 7 squared, right? Rewrite that as x minus 7 times x minus 7 so that we can FOIL. First, outer, inner, last. First is going to be x times x. Outer will be x times -7. Inner is going to be -7 times x. And last, let me correct. Oh no, that's not what I want to do. I don't want to cut any other items off. And let's Here we go. And then last is -7 times -7. From here, we've got x times x times -7, -7 times x, -7 times -7. Let's multiply those out. X times x gives me x squared. X times -7 is -7x. -7 times x is -7x. And -7 times -7 is a positive 49, right? A negative times a negative is a positive. We've got these common terms here that we can combine, and they join together to be a -14x. We've got our x squared out front. We've got our constant term c of a 49 at the end. And there's our quadratic. The goal in foiling is to put it into standard form. When you see something like this, x plus 5 times x minus 6, this is also called factored form. We'll touch on that later, but we're going from this form into standard form, ax squared plus bx plus c. Now, what are some common errors that we could do while we are expanding? Well, for starters, with this squared, you might distribute the exponent. You might do x squared plus 5 squared, so x squared plus 25. That's the most common error I see. You need to be able to do this in Core 2. Literally, this identical stuff is going to show up in Core 2. You're just going to go a little bit deeper, but does it mean you're going to need to know how to do this? Absolutely. And will you be quizzed on it? Absolutely. I actually think I gave this exact problem on a quiz, and I saw x squared plus 25 a lot of times in my Core 2 class. Don't make this mistake. Don't distribute the exponent. It should be x plus 5 times x plus 5. All right, error number 2. What if you don't do all 4 of the foils? Or what if you mix up the foil, like Dielman did? What if you accidentally do the same one, or if you do one of the items the same, or double, right? Because I had x times x times -4, 4 times x, and then I was really having this outer times the outer again. I was doubling up. Incredibly dumb of me. But actually not, because you see this pattern above, and you kind of got to think about it. Okay, I'm starting at the same point going here, starting here, and then going here. If you were to go on the bottom, you start at this 4 and multiply it here, start at the 4 and multiply that there. It's hard to visually keep things in order when there are a lot of visual things you have to do. So, not dumb of me, very common error. Make sure you don't make that mistake like Dielman did. And then last but not least, not combining the like terms correctly. Whether you don't combine like terms at all or you don't combine them correctly. Some of you might see, 5x and 5x, they cancel out. They're gone. No, it's a positive and a positive, so it's 10x. Or maybe you guys might see a 4x and a 4x here and you go, that's 8x. Nope, one of them's negative and one of them's positive. You gotta pay attention to the signs. Those are important. So that's all I have for you today. Tomorrow, you will have a Delta Math practicing this stuff. Mrs. Hernandez and I are posting that Delta today if you want to work ahead and get it done with. That would mean you would have no homework for Thursday. And in terms of your math class, you would have spring break a day early. So if you are somebody who would like to work ahead and get this assignment done with, we'll have that posted for you. We will not assign anything beyond this video and this note sheet and your Delta Math assignment. But that also just means you got to get it all done. So don't procrastinate. If you save this all for Thursday, it's going to be a rough day before spring break. So make sure you have this done. Work on the Delta either today or tomorrow. Either one is fine. No pressure. And we'll go from there. You guys rock. Let me know what questions you have on the Google Doc. I have a fancy new little app on my iPad I got that I can do problems and I can show you work and send you little videos. So let me know what questions you have. You guys are amazing.